Okay, so we're doing some work on data distribution here, and we're looking to tie this whole chapter together. And all I'm looking to do here is make a tutorial and summarize as much of this work as quickly as I can. So I think the place we need to start is just to start thinking about the data itself and the different types of data that we have is either categorical or numerical data. And we can divide that up further. So we have nominal categorical data, and that's just I think of that as nom being equal to name. And whenever we assign a name to something, that's where we're using, for example, colors or whatever. The other division here that we can have is ordinal. And you've got to be careful here because this is where students can fall into a trap here. And the choices that we get, the names that we have, we could call it nominal data, but there's an implied order to this thing from, say, infrequent or never to always and everything in between. So that could be frequent up there. Okay. And the other place where we need to really be careful is we could have some numerical data, but we've put it into maybe for house prices here we're $300,000 to $400,000 here. We've placed it in a category, and the way we're thinking about this, we're thinking, even though it's numerical data, there's some order to this. And maybe if we're talking about houses, this could be a cheap house versus an expensive house here. So we just need to be really careful. And the moment that we start splitting these data or summarizing these data into these types of categories here, we've got some form of categorical data that has an implied order to it. So we've just got to be careful there. And finally, here we've got two types of numerical data. So the way I think about this is discrete, and so we're dealing with whole numbers, okay? Whole number values. And the types of questions where that's important would be something like when you ask how many children are in the family, well, that has to be either 0, 1, 2, 3, or however many. So the numbers are whole numbers, and that's what we're collecting versus continuous data. And the easy way I think about this is if there's a decimal place involved, you are dealing with continuous data. So it, rather than say on the number of line here, taking on discrete values, we can get a measurement in here that could encompass some fraction of a whole number, say 2.1 or something. So we've got a decimal representation of that number, or a fractional part of that number. So bringing this out again, this is a kind of thing. The calculator can't help you with these skills here, and this is the way you need to be thinking about things, and it has an effect on how you summarize the data, depending on what you've got to start with. So that's an important question to ask straight up. So the rest of the questions that we're doing we're asking two questions, really. We're asking questions about where is the center. And when we ask those questions, we're thinking mode, or the most frequent. We're thinking median, which is the middle value, or we're thinking the mean, which is the average. And it might be important to stop here, and by now we might be seeing this symbol here, X bar, what I call X bar, to represent the mean. And if we want to take a little bit of a deeper dive there, this X bar, what I say X bar here, or the mean, that is the sample mean. Because often what we do in statistics is we don't sample the entire population. If we did that, we'd use a different symbol here. But the work that you're dealing with and what you see on your calculator screen when you need to get the value of the mean is this X bar, okay? And that is the sample mean. And that's important because the next question we ask is how spread out are the data, okay? So depending on how we represent the data, we might be looking at the something like the range, which is a really crude way of doing it. We might look at the interquartile range. So that's Q3 subtract Q1. And what we're actually asking ourselves in that situation and what we're doing, we're measuring, I'll just draw myself a quick box plot here. We're measuring the size of the box. And we understand because they're quartiles, there's 25% of the data in that part of the box and 25% there. So the size of the box, we're actually asking where is the middle 50% of the data. And that's what we're asking when we ask for the interquartile range. And that's useful. And the final thing that we ask for is the standard deviation. I think I spelled that wrong. Let's start that again. Standard deviation. Okay. And for us, that is represented on our calculator by something like this, SX, which is the standard deviation of the sample. Okay. We talked about sample means before, and the idea that in statistics we only take a sample. So we need to be really careful on our calculators to understand the value that we need to get and the symbols being used here, because what's generated is two standard deviations. One's for the population and one's for the sample that we've taken. Now, the standard deviation of the sample is a little bit more conservative measure, so it's a larger value. And how that's calculated, so I'm just going to use this standard deviation of the sample. What we use is a formula, and what I might spend a bit of time doing is helping you unpack this formula here and understand it at hopefully a little bit deeper level on what's happening here. So we take the value of the data point and we subtract the mean from that. That's why I'm using that symbol, and that's why I explain that. Then we square it, and then we find an average of those squares. So we get the size of the sample, so n, and we subtract 1. And so that's why it's always a larger value. Then finally, we take the square root of that, even though that was the first thing I drew. It's actually the last thing that we do. So, and what we end up reporting is the mean plus or minus 1 standard deviation. Okay. And that's important that you know and understand that. And often you can get that stuff from the calculator and the way that we go about clicking the buttons, I guess, and generating those things. So it's a job for you to look down and know what to do. But I'm also thinking about just taking the time at the end of this video to help explain what's going on with this formula. And what I forgot to do here, of course, was write the sum of in here, because we do that for each of the data points here, and we sum them up just in a similar way. If I just jump up here and I talk a bit more about the mean, because in this calculation, we need to know the mean before we start calculating those things. So to calculate the sample mean, we just simply take the sum of all the values and then divide by the number of data points that we've got. And we've got an average of those data points there. So that formula, this needs to be done to feed into here if you're going to do all this by hand. So let's take the time now to run through a few questions. And we've got this overview of what we're doing. And as we go through these questions, we can talk a little bit more about why we're doing these things. So there's an interesting question here. We've got 20 babies born at a local hospital, and their birth weights are given in the STEM plot. Great. Find the mean, the standard deviation, the median, and the IQR and range of those things. So what I've done here is that I've cut out the data, and well, this is what I'd like you to think about. We've got this stem and leaf plot here. If we turn it sideways, what we get for free is a look at the distribution of the data. And the data must be doing something like this. And all I know at this stage is the middle is in here. So the mode is in here. And it's a bit hard we can't calculate the mode because we've got two lots of 3.2, 3.3s, two lots of 3.4s, and two lots of 3.7. So we can't calculate that, but we know it's got to be in there somewhere. We also know that the median is in here. And I'm not sure about that just yet. So we can calculate that. We've got n is equal to 20. And the quick way around the block here is that's an even number. So we can use this formula here, 20 divided by 2. 2 is equal to 10. So 1, 2, 3, 4, 5, and another 5 takes us up to here. The data are in order as well. So halfway between the average between those 2 points will be 3.45 kgs. Okay. Now, well, I also understand that the mean of the sample must be in here somewhere. And I wouldn't be surprised if it's very similar to that value. And that's something that we need to calculate. So there's 20 data points there. And when we're looking at this and making a decision, I would say to do something like this. What we need to do is get onto a list and spreadsheet page, and we can quickly generate that information here for us. So I've got 20 data points. I've been checking that. And if I go onto the calculator now, with a couple of clicks here, I can get my summary statistics, one variable stats. That's one list, and birth weight in kgs. That's what I'm looking for. And let's put it in column B. Okay. So the mean is 3.46. And I'll grab the standard deviation in the minute, but I'm just also checking here I did my calculation correct for the median, and I've got it here. So I'm well on my way to answering some of these questions, and I might grab that value for the sample mean, and let's round it off to 2 decimal places. So I'm going to change that to 3.47 and write that down now that I've got that value. Okay, so 3.47. And what I might do is report the standard deviation as well. So plus or minus, and let's come back in here and check what I actually want here. And this is it. This is what I was talking about before, how it set out the standard deviation of the sample. So I've got the standard deviation of the population there. See, the symbol is different, and it is a smaller value. So this is a more conservative measure, and this is the one that we want. So plus or minus 0.64 of a kilogram. And that's how we report the mean at plus or minus at 1 standard deviation. Now, this question asked me for a couple of other things. One of those crude measurements of the spread of the data was a range. So we're talking about the maximum value subtract the minimum value. And in this case, that was 4.5 subtract 2.1. So that's equal to 2.4 kilograms. We've got the range, and that's a crude measurement of the spread of the data. And now we want to get the RQR. And that's going to be Q3 subtract Q1. And we've got the information there. We can look at it on the table, but I might, because this data is in order and it looks relatively easy. So Q3 has to be, we need to cut this data in the upper half of this data in half again. So Q3 has to be somewhere between 4.1 subtract 3.9, which is 0.2, and then let's halve it because it's an average. Divided by 2, so we've got 0.1. So Q3 is 4.0 kilos, and Q1, same story here, where we've got to be somewhere in here, somewhere between 2.9 and 3.1. So that's going to be 3 kilos. So the interquartile range here is 1.0 kilograms. And now I've done that by hand, so it might be worth just checking if I got it right. And here's the other reason why it's worth printing this off, because even if you're doing these calculations by hand and thinking through them rather than just pressing buttons, you can double check and make sure that you got everything right. So to answer this question now, we've done all the jobs. We've got the median, we've got the range, we've got the IQR, and we've also reported the mean and the mean, the sample mean plus or minus the standard deviation. And these two measures of the middle are very similar, okay? And just to think about the spread of the data, the IQR, which is the middle 50%, and it's telling us that 50% of the data are within 1 kilo of each other. And here's the final thing, like let's relate it back to the curve, the normal curve. We've got the mean in the middle, and what are we actually saying when we report the standard deviation? We're saying we're going to subtract one standard deviation here, and we're going to add 1 standard deviation here. So reporting that measure actually helps us get some idea of where, let's just be rough here, 68% of the data are in this area here. Okay, the mean is the middle, so that's there's 50% of the data below that point, and there's 50% of it above that point. So We know that by saying plus or minus 0.64, we're actually saying that the bulk of the data, or 68% of the data, are centered around the mean, plus or minus 0.64 of a kilo. So I hope that's helpful for you, and I might end this tutorial here.